Alright, so let's say you're given this diagram here of pushing a block on a flat surface. The question says you want to move the block of mass 60 kilograms from point 1 to point 2. Since there's an object in the way, you must take the vertical, then horizontal path. How much work must you do if the force of friction with kinetic coefficient 0.2 acts on the object throughout its motion? Since we have a force of friction and a force applied, we must use the energy relationship that includes the contribution from work other, which is given here, where K is the kinetic energy, if you remember, is equal to 1/2 mv squared, and use the potential energy, which in this case is going to be equal to mgh, where h is the height. And work other is the work done by all other forces not associated with the potential energy of the system. We can apply this to our example. So this is our example here, and this is our energy equation. So we can identify this as point 1 and point 2. At point 1, for the kinetic energy, the initial velocity is going to be equal to 0 because the object starts at rest. So that means the kinetic energy at point 1 is going to be equal to 0. The potential energy, the object is on the ground, so the height is going to be equal to 0. This means that U1 is going to also be equal to 0. At point 2, we see this pattern continue where the object ends at rest, so the kinetic energy is going to be equal to 0, as well as the object is still going to be remaining on the ground, so the potential energy is also equal to 0. Plug all these 0 values into our equation. We end up getting that work other is going to be equal to 0 in this case. But what is work other? If you look at our diagram, we have two forces acting on the system. The force applied, which is the force you're applying, and the force of friction, which is acting against the force applied. So there's two contributions. There's going to be work A, which is the work done by the force applied, and then there's going to be work F, which is the work done by friction. Work other is going to be equal to the summation of these, also equal to 0, so we can isolate for work applied, and we get this relationship here. The work you have to apply is going to be equal to the negative work done by the force of friction. If we find the work done by friction, we can find the work applied. We know that in general, work is equal to force times displacement. So if we look at our diagram here and we look at the first part of the motion, the vertical part, we're going to have force of friction going up and we're going to have displacement going down. We can also write the work equation to this form here where it's equal to the amplitudes times the angle between them. We can identify that the angle between them is 180 degrees. And then our friction equation is going to be equal to mu kn. This is the force of friction equation for kinetic friction. And so we could plug this in and then we can plug the known values of the question where n's the normal equal to mg. Plug all these in, we can compute the amplitudes in the units and we get this answer here for the work due to friction between point 1 and this point here on the diagram. We still need to find the amount of work due to friction going from this point to the final point, point 2. This is going to be found using the same process. So if we look at our diagram here, we need the work from this point to the final point, point 2. So friction is going to be pointing in the opposite direction of displacement, just like before. And if we follow the same procedure, we can find that the final work due to friction for this displacement is equal to this. So the total work done by friction between point 1 and point 2 is going to be equal to the addition of these two values we just found. And if we do that, we get this. If we remember original relationship here, we can find the work applied by just taking the negative of the work due to friction. And so this is the final answer for the total work that needs to be done to move the object from point 1 to point 2.